Anyone who has tried to follow a badly written recipe or assemble furniture with missing instructions knows how frustrating disorganized logic can be. When computer programs lack clear structure, they turn into a tangled web of confusing instructions. Developers call this spaghetti code. It happens when instructions jump around without a clear path, making the program difficult to maintain and a nightmare to debug. You can avoid this by following a specific architectural framework. Regardless of how massive or complex a piece of software seems, it is built using just 3 simple logical structures. You don't need any prior coding experience to use them. These structures rely on the same everyday logic you already use to complete tasks and make decisions. Understanding these 3 building blocks allows you to organize your logic so it remains readable and easy to manage as your projects grow. The first and most straightforward concept is the sequence structure. The core rule of a sequence is linearity. Tasks must be executed in a specific order, one after the other, without any branching or skipping. This is easily seen in a physical process like making French toast. You have to prepare the mixture first, dip the bread second, and cook it third. If you change that order, the process fails. Computers read code in the same way. Whether looking at Java, Python, or C++, machines follow instructions sequentially, top to bottom. Because of this order, you declare variables and perform calculations before printing the final result. Sequence is the baseline of all programming. It guarantees that operations occur exactly in the order the developer intended. The second building block is the selection structure, which allows programs to make choices based on dynamic conditions. In a dual alternative scenario, a single condition forces a path choice. At the if diamond, execution goes down either yes or no. For example, if you have a car, you drive to work, else you face the consequences. In code, this splits the logic into 2 blocks. If the age is 18 or older, the program runs the voting approval block. If not, it drops to the else block to run the denial message. Contrast this with the single alternative scenario. Here, an action is only taken if the condition is true. If the condition is false, the program simply bypasses the action and moves to the next instruction. This simplifies your code when no fallback is needed. In this temperature check, if it isn't hot, the program doesn't need to do anything. It simply continues to the next statement. Choosing between these depends on whether your logic requires a fallback. If you use a single alternative when a response is needed for every outcome, the program will ignore any false conditions, which can lead to unintended behavior or missing data. The final building block is the looping structure. Loops repeat a process efficiently, so you don't have to write the same lines of code over and over. A while loop repeats an action as long as a specific condition remains true. As long as there are more stairs to climb, you take a step, and the program cycles back to check the condition again. The most important rule for any loop is that the condition must eventually become false. Without a trigger to exit, the loop will never stop. You create this exit trigger by modifying a variable on every pass. In these scripts, commands like stairs minus minus reduce the count by 1 each time, ensuring the loop eventually reaches 0 and terminates. If you forget this exit modifier, the program gets trapped in an infinite loop. It repeats endlessly, usually causing the software to crash. Loops provide significant computational power, but they require you to manage the exit condition to ensure the program moves forward. These 3 patterns, sequence, selection, and loop, form the foundational logic used in modern software development. Complex programs are built through nesting. This means placing these structures inside one another, like a selection decision inside a loop within a sequence. To keep logic modular, structures should only combine at 1 entry and 1 exit point. Sticking to this modular design is what prevents the tangled spaghetti code we discussed at the beginning. It keeps your instructions clear and organized. To practice, try mapping out a daily routine, like making coffee or commuting, using flowchart shapes. If you can diagram a routine's logic, you can architect the logic of a program.